Welcome again to the Matlab tutorial video. So today in this video, we are going to focus on a few of the Matlab functions in which we will look at how to create the matrix in a Matlab and how this matrix multiplication can be done. And if we wish to do the multiplication element by element, how the same thing can be performed. One more important topic for the today's discussion is how to go for the plotting of different waveforms and how we can use the subplot functions. So let's begin the discussion how we can create the MATLAB function matrix in the MATLAB and how this matrix can be multiplied. So here we have this command window. So I already explained you the introduction part in my previous video. So first of all, we need to clear all the functions, all the variables which we have generated due to the execution of our previous programs. Okay, so here you can see that in the workspace window, we already have a certain variables that we need to clear. So first I will be writing a clear command, and here we can now suppose if we wish to generate a particular, let us say that this array is donated by the variable capital A, okay, or let us say represented it by some ARRAY, okay, array. Writing this variable name as a. So if suppose if I want to generate a particular array in which one element, so let us say that these elements are 1, 2, 3. Okay, so it is containing three elements. So this can be written in this way. First we have square bracket, and then we have to write the values, and then it should be separated by. You can also write here comma, but it may also work if you put the space in between the two elements. Okay, now you have to close this square bracket, and if you enter this and if you press this enter button onto the keyboard, you will be getting this variable name as array, and it is containing value 1, 2, 3. Okay, so it is having three different uh, elements in this particular array. We can have any number of element in this particular array, okay, based on our requirement, right? So here you can see this particular array is actually what is the size of this particular array. If we talk about what is the size of this particular variable and that we have defined as array, okay, what is the size? So if you wish to see the size, you can see it is containing 3 columns and 1 row. Okay, so if you see, if you write like size of this particular variable array, then you will be finding that this size is 1 into 3. Okay, there's number of rows and number of columns. Okay, first is number of rows is 1 and number of column is 3. So definitely it is this array is nothing but your one of the matrix. So whose dimension is equals to 1 and columns equals to 3. Similarly, you can make this particular matrix of any size. So if you want to make any matrix, okay, let me say this matrix as make a 3 cross 3 matrix, then how it can. So you can open this square bracket. If you directly want to write a particular element value here, you can write those values. For example, I'm writing over here 1. This is denoting our first row. Then the column, yes, this is the first row and 3 columns. And then I can separate our second row by putting this semicolon. Okay, and then I can write the other elements. I can separate out this third row, and then I can write the other element values. Okay, so this way, if you write, you have to close this square bracket, and if you press the enter button, you will be getting this matrix with the name of mat variable, okay, which is having a 3 cross 3. And this is the elements 1, 2, 3, 4, 5, 6. Whatever the value that you want, you can substitute over here. I'm just taking for example only. Okay. Let me take another matrix, which is again a 3 cross 3 matrix. So if I 2, suppose Carlo, if it is matrix 2, then mat 2, you can substitute some values. For example, it may be like 3 comma 2 comma 1. Separate out this like 6, 5. Here, if you see this matrix 2 is again having cross 3. So suppose now if you want to multiply this two matrix, so you must be aware that how this matrix can be multiplied. Okay. How this matrix can be multiplied? The matrix can only be multiplied when the number of columns in the first matrix is same as the number of rows in the second matrix. Then only we can multiply. Okay. So this column is going to be multiplied with the rows. Okay, and then that way you will be able to get the result. So please follow the matrix multiplication rule. And here I can give another variable name, which is result. Okay, matrix multiplication mat. First matrix is mat, and then the second matrix is mat1. When you put this star sign, okay, this asterisk sign here, it means that we are going for the matrix multiplication, and that time we have to be very sure that this two matrix dimensions are same. Otherwise, it is not going to. I mean, it is following the its inner dimension of the two matrix should be same. Otherwise, it is not going to multiply, and it will be going to give you a certain. So if you do this multiplication, you can find there is a see what is this mat1. Okay, so sorry, it is a mat2 we have defined. Okay, so you just write mat into mat2. Okay, it is a mat2. We have not defined as mat1. That's why it is showing is undefined function or variable mat1. So here you can find this result as mat into mat. I'm going to give you the matrix multiplication result. So this row is going to be multiplied with the. So you can see that how it is multiplying. So 1 cross 3 plus 4 cross 6. So 1 cross 3 is equals to 3. Similarly, you can do the multiplication. Okay, so try to do this multiplication. You will be able to find out the matrix. Whatever you are getting, it is the multiplication of the matrix. Fine. So this way you will be able to prove whether you are getting the right result or a wrong result. So that way we have to prove. Fine. So this way we are able to get this matrix multiplication. Okay. But suppose if you don't want to go for the matrix multiplication, but rather if you wish to do the element by element multiplication. So the meaning is that the first element, okay, this is 1 comma 1, first row and first column element should be multiplied with the first column and first row of the element of your matrix 2. And then similarly, you want to multiply the second element with the second element only, and here third element with the third element only. Okay. If you wish to multiply element by element, okay, then how this can be done? So the same thing again, I can do this multiplication. So let me write this variable as RR. Okay, so if you want to multiply this, it can be written as mat, and then we have to put one dot sign over here, dot, then it is a star, and then again mat2. Okay, so if you write this way, you will be able to verify that what result we are getting. Okay, so see what is mat and what is mat2. Okay, this is our mat. So first of all, you can verify these things. Okay, this is 1 is multiplied with the 3. So the result will be 3 only. Then 2 is multiplied with the 2. So 2 into 2 is equals to 4. And here 3 is again multiplied with the 1. So the result should be 3. Similarly, this 4 is going to be multiplied with the 6. Okay. The result should be 24, that you can verify here. Okay, it is 24. Then this 5 is multiplied with the 5, you are going to get 25. So this way we may be able to get the element by element multiplication. Okay, so you remember this dot operation, dot star. Okay, that will be used for the uh, element by element multiplication of a matrix. Okay, but if you wish to multiply the matrix only, then you have to follow the matrix rule. Okay, otherwise you won't be able to multiply. So that you have to remember. Okay, you won't be able to multiply. So that you have to take care. Now you can just verify this result. Okay, you just verify this result because we are multiplying this matrix with this matrix. Okay, so you have to verify this result. Okay, this should be following the matrix multiplication rule. So you will be able to get this 42, 36, 30, and so on. So that you please verify. Now here you can see, suppose we are generating another matrix. Okay, let me say matrix 3 that some dimensions, because you see what should be the dimension of the two matrix, because the first matrix that the dimension is 3 cross 3. So the second matrix should have the number of rows equals to 3. So let us say that if I'm not having the number of rows equals to 3, whether it will be able to, it is this. Okay, you can see this matrix 3 is having number of rows equals to 2 and number of columns equals to 3. So if you wish to multiply matrix, multiply first matrix and then multiply it with the matrix 3, then this result, what it is displaying here is, it is error using a multiplication. Okay, so it is the incorrect dimension of matrix multiplication, and therefore it is not possible to do the. So while doing the multiplication, you have to follow the matrix, and only you will be able to multiply. Hopefully you must be able to understood how this element by element multiplication and matrix multiplications are different. Okay, it is serving the two different purposes. Fine. So now in the previous video I explained you that how to square a number. Okay, so suppose if we have this particular so let us say that we have another variable x. Okay, you just define it like this. Let us say that we have the variable 1, some variable 1, and this variable is containing 5 elements. Okay, so let us say that this variable is containing 1 to 5. Okay, so how this variable can be generated, you can write over here 1, you can put the colon over here, and then you can this way we can also generate this particular array. And here you can see that it means that this array is going to contain the value right from 1 up to 5 with the step size. By default, step size will be 1. Okay. So this value will be incremented by 1. It will be started with 1 and it will be incremented by value 1, and it will go up to 5. Okay, so this variable 1 is having these 5 elements, 1, 2, 3, 4, and 5. Now suppose if you wish to square this value. Okay, how? So you must be thinking, if you want to do the square, I can write variable 1. So if you write variable 1 multiplied with the variable 1, okay, uh, obviously this is not going to serve the purpose, because here you can see how many rows and how many columns that we have. We are having 1 cross 5 dimension. It is 1 cross 5, and again we are multiplying 1 cross 5. Okay, so it means that its inner dimension is not same, and when you multiply, it will be giving you some error. What we can do is, rather we have to put the dot sign, because we have got the element by element multiplication. So if you put one dot sign, you will be able to see that each element of this variable 1 is going to be squared. Okay, here you can see that each element is going to be squared. It is 1 square, it is 2 square, So this way you can do the squaring function or any, there may be some other way of doing the same thing, like is we can put this exponent sign like this, and then here we can put 2. Okay, so that will also serve the purpose and it will be giving you the same result. So this way we can do the squaring. Now one more important function that we are going to look at about the how to go for the plotting. Okay, so in the previous lecture, I already created this particular program. Okay, so I'm just going through the same code. Okay, so we already generated this plot for x and y. So suppose that if we wish to plot the multiple plots, okay, so there is another command which is known as the subplot. So suppose if we wish to plot the multiple plots in the same figure window, there will be a subplots. Okay, so how to generate a subplots, that we have to understand. Okay, so let me say this x we have generated, which is minus 10 to 10 it is varying, and we have generated another variable y which is equals to x squared. Let me introduce some, we have to generate few more variables. So let me take another variable time t, go to some step size I will be taking, which is very, it should be very small. Okay, so if it is, let us say it is something 0.0001, and it is going up to 0.1. Okay, this is the variability that we are taking, and let me take the variable yt. Okay, I just take yt, which is a sinusoidal function. Okay, let me take this. Know that in the sine function, we need to define 2 pi, and then we have to take the fundamental frequency. Okay, we have to take the frequency of this wave. So let me say if this frequency is something 50 hertz. Okay, so let me take 50 hertz, and then we have to take this t. It is going to generate a particular array of sinusoidal signal for this particular values of t. Okay, so whatever be the values of t we have defined. Okay, so I'm just copying the same thing again. Okay, and then I will be generating see, we have already defined the value of t, so it need not be changed again. So I can take another yt1. Okay, I'm just taking y, then I will be changing the frequency of this. So let me make it 100 hertz. I can generate another yt. Okay, here we have this function as yt. Okay, so here you can see that how many different plots that we can plot. Okay, here we have x equals to minus 10 to 10. Then we have to make a plot between x and y, and here we can plot between t and yt, and here we can have in between t and yt1, and here we can have. Okay, so this way we can have the different. So essentially, if you wish to have the subplotting, then how this subplotting can be done? So here you can see how many plots we are going to have is we are going to have the total number of 4 plots. Okay, so I will be defining a subplot, and this subplot will be actually, this 4 plots will be divided into like a 2 cross 2 matrix. Okay, so one plot will be here, and then another plot will be at this here. Okay, so there will be a 2 cross 2 means I will be dividing the entire plot into 2 cross 2 subplots. Okay, so there will be 2 rows and 2 columns. Okay, so first of all I will be writing here this dimension 2 cross 2. Okay, we are dividing the plot into 2 cross 2 subplots, and this is our first plot. Okay, so where I am plotting is that number we have to get. Okay, so here I will be plotting this, and then again plot x comma y. Then again I will be writing this. Okay, so I have to go for the subplot, but now we have to change the location of our plot, and that will be 2. Okay, So this is 2, and here we have to change the variable. Here it is t, and it will be yt. Okay, so this way we have to write, this should be yt, just make it yt. So this is this function. This function is going to be, again I can copy and paste the same thing. Okay, so if you do that, you will be getting another plot. Now you have to just change the location. It is at the third position, and here it should be yt1, and then again here I can have this set 4, and here it is yt2. Okay, so if you write in this way and if you execute the code, we will be able to see what we are getting. Okay, so here you can see, okay, here we are able to generate this plot. Okay, and here you can find that in the first place. Okay, in the first place, first of all, we have one figure window, and within the same figure window we have the subplot of 2 cross 2 dimensions. Okay, 2 rows and 2 columns. Fine. And at the first location, okay, at the first location, here you can see, here you can see this first location in which we have done this plotting. Subplot 2 comma 2, it is first location 1. Here we have plotted x comma y. Okay, so this is our first plot. Similarly, subplot 2 comma 2, again comma 2, means it is the second location. So how this location will be counted? 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. This way it will be counted. So in a similar way, we have this plots. Okay, here we have the cosine function. So this cosine function has been started from this. So you can just enlarge this one and you will be able to see this particular function. Okay, so this way we will be able to get this plots. Here one more thing that you can observe here is that this plots of these two sine and cosine function, when it is of 100 hertz, it is not very much clearly visible. Okay, so it is not having its pure form. You can see it is a little bit distorted here. So how this can be corrected is that we have to just increase or decrease this particular step size. Okay, we have taken this step size 0.001. So if you further reduce it a little bit, okay, if you reduce it a little bit, you will be able to see that due to this reduction, a very smooth plot will be available. Okay, here you can see that this smoothness of the plot has been increased. Okay, because it is having of 100 hertz frequency and it was 50 hertz frequency. So this was not actually affected very much, but here it was a little bit. What we did is we just increased the, means we reduced the step size. Okay, so if we take the samples at very small distance in time, that time we may be able to get the very smooth plot. Okay, so that you have to remember. Fine. So hopefully you must be able to understood how this subplot functions can be used, how the matrix multiplication can be done, how the element by element multiplication can be done. You remember that how we can generate a particular variable, okay, and how means particular array, and how we can define the particular step size. Okay, so this you have to remember. Okay, if you don't put anything, suppose if you don't put anything, like in this case, if you don't put the step size, okay, normally the by default the step size is 1. Whenever the by default step size is equals to 1, we don't need to define it. Okay, if it is other than 1, then only we need to define the step size. Okay, so even if you execute it, you will be able to get the same result, even though you have not defined the step size, because by default the step size is equals to 1. So I hope you must be able to understand this video. If you have any further query, let me know with your comment in the comment box. And please stay connected with the channel for more updates. Thank you for watching this video.